This video is about solving linear inequalities. The solution of an inequality is a value that makes the statement true, any value that makes the statement true. So with an inequality like the first example shown here, x is less than or equal to 3, there are an infinite number of solutions because there's an infinite number of possible x values that are less than or equal to 3. It includes 3, 2, 1, 0, -1, -2, -2.5, right? And it goes on forever. So it's asking us to graph that solution set. It wants a visual representation of all of those possible values for x. So if you don't have a number line already constructed, you have to start by drawing a number line. It's a horizontal line with the tick marks evenly spaced out, and we need to somehow get the number 3 up here. Now, if it's reasonable for me to put 0 on my number line, I like to do that. It provides a little frame of reference for the other numbers on the number line. So if 0 is here, this is 1, 2, 3, this is -1, -2, -3, etc. And I want to shade in all of the numbers that are less than or equal to 3. So to shade in numbers, I'm going to start with the 3, since the 3 is one of the solutions here, because it does say or equal to, right? This symbol means or equal to. So start by shading in the 3, and then I want to shade in every value that is less than that 3 also. So to shade in values, there are many ways to show it. I like to just darken in the actual number line right on it, and darken in the arrow to show that this solution set continues in that direction forever. And that's a visual representation of the solution set for x is less than or equal to 3. The next example is only slightly different. It's x is greater than -1, and it does not include the or equal to symbol underneath. So I'm going to still put 0 on my number line. It's reasonable to fit it here. I have -1 on the left, +1 on the right. To show the solution set of x is greater than -1, I don't want to include the -1 since it's not one of the solutions. But every single number that's greater than it, including -0.999999, is a valid solution. So I want to start at the -1 with what we call an open circle to show that I'm starting from there but not including that, and then shading everything that is greater than a -1. So towards this direction, and shade in the arrow to show that it goes forever in that direction. And that is the solution set to x is greater than -1. So closed circle if it's or equal to, open circle if there is no or equal to. A compound inequality consists of two simple inequalities joined by either an and or an or. So you can see in the first example versus the second example, the second example actually has the word or in between, and that's because x can either be less than or equal to -1 or greater than 4, but there's no possible way for a single x value to be both less than or equal to -1 and greater than 4. So the second example is an or. The first example is an and inequality, and you don't see the word and because they've put these two inequalities together. X is literally in between -1 and 3, and it's possible for there to be a single x value that is higher than a -1 but lower than a 3. So that's the difference between an and inequality and an or inequality. To shade the solution set for the first example, I want to include all the x values between -1 and 3, but not including -1 and 3. So it's reasonable for me to put 0 on here. There's my frame of reference, 0, and I labeled at least out to the numbers that I need represented. And then I want to shade in between the -1 and the 3 with open circles on the -1 and the 3 to show that I am not including those values. And that's the solution set, which is different from the second example. Here we have -1, 1, 2, 3, 4. Here we are including the -1. It has an equal to sign underneath it. And we want to shade everything that is less than it. Or x could be in the set of numbers that are greater than 4. So not including 4, but including everything greater than it. And that's how you graph that compound inequality. As inequalities get more complicated, you may have to solve the inequality to find out what the solution set is. So the example that's given here, you can't just put that on the number line. You need to isolate the x first to figure out what x is either greater than or less than. There's one additional rule to remember when you're solving this equation or this inequality for x, is that you must flip any inequality sign when you multiply or divide by a negative number. So I've chosen an example so you can see what that's going to look like here. Take the inequality, get x to one side. I'm going to subtract 5x to illustrate this point about the negatives. So So 5x minus 5x is 0. 3x minus 5x is negative 2x. I like to isolate the x on the left side of the inequality so that my final answer has the x on the left. It's just a little bit easier to read when it's an inequality. So I've got my x on the left. I'm going to subtract this 2. Start isolating this x on the left side of the equation. Bring down what you have left. Negative 10 minus 2 is negative 12. And at this point, I need to divide by negative 2 on both sides to isolate the x. When you divide by a negative in an inequality, you must flip the inequality symbol. So what is currently a greater than sign will be a less than sign in my final answer. Negative 2 divided by negative 2 is 1. Bring down the x. Flip the sign, and negative 12 divided by negative 2 is positive 6. So this is the final answer. It doesn't ask me here to graph it on a number line, but if you're asked to graph your solution on a number line, make sure that you include that next to your answer. It's reasonable for me to put 0 on here because 6 is not that large of a number. I can fit up to 6 on here. 1, 2, 3, 4, 5, 6. And I'm asked to shade everything that is less than 6, but not including 6. And that's what the solution set would look like on the number line. To solve an and inequality, also known as a conjunction, if the variable is only in the middle, you solve it as if it's like a three-headed equation, and you're going to isolate the variable in the middle. So I have this 6x in the middle of the two inequality signs, and I'm going to isolate the x in the middle there. I can start by getting rid of this 10, add it to all sides of the equation, like a three-sided equation. These cancel out. Negative 4 plus 10 on the left is 6. Bring down what you have left in the middle. 14 plus 10 is 24. And then I'm almost done. X is almost isolated in the middle. Now I need to divide by 6. Divide all three sides by 6. This is a 1. This is an x. 24 divided by 6 is 4. Now this would be much more complicated if the x was on the left and the right and in the middle. You'd have to solve it much differently. But for the sake of x being only in the middle, you can just solve it like it's a three-sided equation. And then graph the solution on a number line if you're asked to do so. To solve an or inequality, also known as a disjunction, they are already written as two separate inequalities, so you just solve them as two separate inequalities, and then just graph the two solutions on the same number line. So solving the inequality on the left, we subtract 5. 3x is less than 6, so x is less than 2. Solve the one on the right. 5x is greater than or equal to 20, so x is greater than or equal to 4. Put the word or in between them. So x is less than 2 or greater than or equal to 4. Graph these solutions on the same number line. It's reasonable for me to put 0 here. 1, 2, 3, 4. Open circle at 2 and shade less than it. Close circle at 4 and shade greater than it. That's the solution, or the graph of the solution to this inequality. Now there are two symbols that you may also see in conjunctions and disjunctions that are not anywhere else on this video, so I'll show them to you here. If you ever see the symbol x is less than 2, and then there's like a large U symbol, like that in between the two, that's another way of writing or. Okay, and if you ever see something like x is less than or equal to 2, an upside down version of that symbol, so let's say this time it's less than 2 and greater than -1, because that is possible. This symbol means and the way I remember which one is and which one is or is that the upside down U shape is kind of like an A. If you imagine filling in the dotted line there, it's kind of like an A for and. So the normal U shape is a symbol that means or, and the upside down U shape is a symbol that means and. So it's another way that you might see conjunctions and disjunctions written. And that is all.